Could you guys hear me and see my screen?
Yeah.
Sure.
Nobody else?
Yes.
Yes.
All right. So let's get started. So I'm going to continue with the real numbers today. I'm going to continue with the real numbers today. And we're going to learn some more properties and rules about them. Okay, once we learn those properties, we're going to talk about how to use them to simplify longer expressions and operations. So let's start with the first property here. So we're going to call that the commutative property. So that's the first one here. It's a simple one. It basically means when you add in two numbers, let's say we add in 5 and 3, it's the same as adding 3 to 5. As you can see here, even though the order changed, the order here changed of the numbers, we still have the same, pretty much the same result. So we call this the commutative property of addition. Okay, and the same thing applies to multiplication. So when you multiply 4 by 2, for example, it is the same as 2 by 4, which is 8. Has nothing to do with this 8. These are two separate examples. This is for multiplication, so we call this the commutative property of multiplication. Okay, so that's all that it means. The commutative property, the order of the numbers change, the result remains the same. This does not apply to division for obvious reasons. When you take, for example, 2 divided by 1 is not equal to 1 divided by 2. Same thing with subtraction. If you say 8 minus 3 is not the same as 3 minus 8. This is equal to 5, this equals negative 5, as we saw last time with the signs. So this does not apply to division and subtraction, only applies to addition and multiplication. So the first property, the second one, is called the associative property. And for this one, we're going to need more than two numbers. Let's say we want to add 3 to 2 to 7. Okay, and we need to do these. We can do these in different ways, but get the same results. Okay. So we can either start from here first, or we can start from these two first. According to the order of operations PEMDAS, what do we do first? For example, here in this one, where do you start from?
In the parentheses.
That's right, so we're going to start from parentheses. So we're going to evaluate this first, 5 plus 7, which is 12. But for this one, we have to start from parentheses also. So if we do this first, we end up with a 9 plus 3, which is 12. As you can see, we get the same result, even though we did this a little differently. So here we associated these two, that's why it's called associative. Associated these two, then added to 7. Here we associate these two and add the 3. So that's what we call the associative property. This one is of addition. Okay, that also applies to multiplication. It does not apply to division and subtraction. So let's see an example of multiplication. Let's say you want to multiply 2 by 4 by 3. You can do it in two different ways and still get the same result. So we can associate these two or these two first. Again, parentheses first, so that's 8 times 3, which is 24. Over here, we have to start from here, so that's 12 times 2, which is also 24. as you can see again, these are the same, even though we did them in a slightly different order, because the parentheses have the priority in the order of operations. So if we want to impose a specific order in an expression, you use the parentheses to basically give priority to an operation or specific number or a couple of numbers over the other number. So that's what we call the associative property, in this case, of multiplication. Okay, so that's the associative property. Let's do another one. Number 3 is called the identity property. And this one here involves, let's say you want to add, when you add 0 to any number, let's say you want to add 0 to 3, the 0 doesn't change much from the expression, so it's still the same. 0 plus 3 is the same as 0 plus 3, or 3 plus 0, which is 3. For any real number x could be negative, positive, decimal fraction, whatever it might be. Same thing, if you add 0 to it, what is x plus 0? For any number?
X.
That's right, x plus 0, any number stays the same. It's the same as 0 plus x, which is x. So this is what we call the identity property of addition. And we say that 0, the number 0, is the identity addition. Okay, 0 is the identity of addition because 0 does not change addition. Okay, 0 is useless or worthless when it comes to addition. If 0 is the identity of addition, what is the identity of multiplication? What number is the identity of multiplication? Everybody? If 0 is the identity of addition because it does not change the addition, what do you think that the identity of multiplication is? What number is the identity of multiplication, or the number that does not change multiplication? You take, for example, any number times 1. Will anything change if you times a number by 1? Nothing changes. 7 times 1 is the same as 1 times 7, which is 7. For any real number x times 1 is the same as 1 times x, which is also itself x. That's why we say 1 is the identity of multiplication. Okay, 0 is for addition, 1 does not affect multiplication. That's the identity property. Let's move on to another one. This one is called the inverse. Inverse property. This one is also pretty simple. So we have 2 of them. We have one, we can say identity or inverse property of addition. It just involves if you take a number basically, as we did last time with the number line. Take a number and then what is the opposite of -3 again? Everybody, what would the opposite of -3 be on the number line like we saw in the previous lecture? Hello everyone. This is not a difficult question. What is the opposite of -3?
+3.
Right? Any number on the number line has an opposite to the other side of 0. So opposite. Now, I believe we saw this property last time. What happens if you combine a number and its opposite? What is this equal to?
0.
0. Right? These cancel out. We get 0. The inverse property, or we call it the additive inverse. Additive inverse property. Same thing. Let's say you have +2. Of course, the opposite of +2 would be -2. Same thing. Or for any real number x, not just that. For any real number x, we take, for example, x. The opposite of it would be -x. And of course, if you combine x or +x with -x, they cancel each other out. You get 0. So keep that in mind. These and this one and this one cancel each other out. That's the inverse property of addition. Combining a number and its opposite is basically 0. So whenever you see x and -x in an expression, they don't have to be next to each other directly. You cancel them out. Now let's see the one of multiplication. This one is slightly different. It involves, let's say, you take a number or a fraction. Instead of getting the opposite, so for the inverse property of multiplication, we get the reciprocal. Okay, instead of the opposite, we get the reciprocal. What do you think the reciprocal of 3/4 is? Not the opposite, the reciprocal. Anybody want to take a shot? 3/4, the reciprocal. What is it?
12.
No. So we have 3/4. It's a fraction. We want to get the reciprocal of it. You just need to do something with the fraction. We basically just flip it. 3/4. The reciprocal is 4/3. And when you times a number here, for example, this one by its reciprocal, what do you think the product or the result is? What do you get over here? So which way do we multiply fractions normally?
It's going to be 12/12.
Exactly. So it's going to be very good. So we're going to multiply, fractions are multiplied straight across as we saw on the first day. And it will always be same thing or something over itself because it's a number and reciprocal and it's always going to be 1. So you don't even have to do the multiplication. If you see a number times its reciprocal, immediately turn that into 1. Put any real number x, for example, right? What is the reciprocal of x? X or 1 or x/1. What is the reciprocal of it? 1 over
x.
X, that's right. Now, if we multiply this by this, what's the product? What is the result? It will be any number times its reciprocal will be
x or 1.
1/1x.
That's right. No, just 1. Just 1.
Oh, okay, just 1.
Or 1/1. We can think of it this way also. The x's cancel out. You get 1/1, which is 1. So, and again, any number times its reciprocal, you can just write 1 right away. No need to do the math. Let's say you have, for example, some random fraction, 105 times 43. You times that by the reciprocal, which is 43 over 101. What is this equal to? Do we need to do the math to figure out, or this would be? The final result would be 1 over 1, 43. A number times its reciprocal again will always be, just like we saw here, would be 1. Okay? Because it's a fraction times by not itself, but its reciprocal. The result will always be 1. No need again to do the multiplication because it's going to be the same thing. 1 over 1 times 43 over 43 times 101. So it's going to be something over itself, which is 1. So keep that in mind. If you see this, you can take advantage of it. No need to multiply. Or you can think of it this way, as we saw with the fraction. We simplify first. We can cancel this against this, cancel this against this. Nothing left here, but some invisible ones. 1 over 1 is 1. So that's the fourth property. Again, the inverse property of multiplication. It involves the reciprocal. The inverse property of addition involves the opposite, which basically means change the sign. Reciprocal means flip the fraction or flipping the fraction. The fifth and the last one is called the, I'm sure you're familiar with it, the distributive property. I'm sure you've seen it or used it before, distributive. This pretty much means when you have, let's say, 3 times 4 plus, let's say, 6. So it's 3 multiply in parentheses. Let's make this 4x. What would this be equal to if we multiply it? We distribute this, you get 3 times 4x, which is 12x. And then multiply again, 3 times 6, that's 18. When you multiply this way, we call that the distributive property, because we distribute one number over 2 numbers here or more. If it was just 1 against 1, we call it a multiplication, but this is a distributive property. Basically, you cannot multiply more than once. The signs could be any signs here. They don't have to be exactly this. We could have, for example, -2 times x minus 1. Same way, we're going to distribute. What would this be equal to? The first multiplication. What's -2 times x? Everybody, what do you think of this? -2 times x. We saw the rules of multiplication and the sign last time. Say that again?
Would that be -2x?
That's right. Negative times positive would be -2x. And then?
Wouldn't you?
Again, this one.
That'd be, would we slash and dash that minus sign?
No, we're just gonna times the 2 signs. Okay. We multiply -2, then we multiply again. That would be?
It would be 2.
2 positive plus 2. Negative times with negative, as we saw last time, is positive. And that's pretty much how you distribute. You just multiply. You use the rules of multiplication here, as we learned last time. Another problem or another example is you may have, say, -3x plus 2. Same thing here. It's basically a negative times this inside. You see a negative in front of parentheses, think of it as a -1. So -1, then do whatever you would do with any other negative number. For example, here -2. What would this be equal to? -1 times -3x. would be what's negative times a negative? I mean, just like this one here, negative times a positive. Here we have a negative times a negative, which will be positive 3x. Then you have negative times a positive. Negative times a positive would be negative 2. Again, we're using the rules of multiplication just like we saw last time in the previous lecture. So that's basically the properties of real numbers, 5 of them. Okay, they're pretty easy. Each one in itself is easy, but make sure you distinguish between all of them. You might easily confuse them. So make sure you can remember the name of each one. I'll also be able to name one if it's given to you, or complete it, or complete one of its properties if it's given to you with a missing number. So now we're going to move on to see how to apply these, all these rules to simplify some expressions with a bunch of x's and y's. Let this be number 1, the properties. Okay, so the properties are these. And let number 2 be the basically simplifying algebraic expression. So the first one was about properties. Number 2 would be about simplifying expressions using these properties. Simplifying expressions. Before we work with expressions, let's first define them, see what they are. Okay, so we're going to call this, let's say, this is an algebra class. The reason why we call it algebra, it's because it has algebraic expressions. We're going to be dealing with a lot of algebraic expressions throughout this course. So we need to understand what an algebraic expression is. Can anyone try to give us a definition of this type of expressions in a sentence? It's a very short sentence. What is an algebraic expression, or what is it made of? Anyone want to try? Okay, it's pretty simple. An algebraic expression is basically a combination of numbers and letters. Letters such as these, x for example, which we also call variables. That's all there is to it. So an algebraic expression is basically a combination of numbers and letters. Examples, say 2x plus 1, for example, 4x minus 2y plus 3. It's another one. You may have, say, x divided by 2y plus 4. So just a bunch of numbers and letters together with some operations. Different types of operations may also be 3x to the second minus, let's say, 4x plus 1. We actually talked about this before when we did the evaluation and algebraic expressions. Yeah, we've talked about this as we saw how to evaluate them by plugging numbers into them, substituting x's or y's with their values and simplifying them. So this is basically just a continuation of that. Okay, so that's what an algebraic expression is. Numbers and letters together. Could be different powers, depends. Now let's see how to simplify these expressions. Sometimes when the expression is too long, we can try to shorten it up a little bit and combine its like terms to make it simpler and shorter. So let's see how to do that. So simplifying. Here's a simple example here, 3x minus 4y minus 2y, 2x plus 7y. So basically we have an expression here with 1, 2, 3, 4. We call these terms 1, 2, 3, or 4 terms. We can make these, we're going to see if we can make this expression smaller by combining what we call like terms. The term is this, this, or this. So for example, this is a term here. Each term has the number here in front of the x that's multiplied by the variable is called the coefficient. It's not an addition or a subtraction. If it's an addition or subtraction, this is not a coefficient. It has to be directly next to the variable, meaning there is a multiplication here. We have a variable. And of course, 2 is the exponent or power. That's what a term is made of. Look for a coefficient, the variable, and the power. That's a variable term. It has a variable. Or the term can be just a number like this, which we call a constant. A constant doesn't change, okay? It's fixed. It's just this value. However, a variable term, for example, this one can change depending on x. If x is 5, 2 times 5 will be 10. If x is 7, 2 times 7 will be 14, and so on, as we saw before when we simplified algebraic expression. I mean, when we evaluated expressions like these. So that's the definition of a term. Here we have 4 terms. Is there a way to make this expression smaller and shorter working with these terms? Can we do anything here? Can we combine anything in order to make this smaller and simplified? Everybody, I'm waiting for your opinions. How do we simplify this expression?
When we add the x's together and then the y, so we add 3 plus 2, which is 5x plus, is that 11y?
Okay, that's the way to do it. That's very good. We combine like terms.
Yeah, combine like terms, my bad.
Right? Combine like terms. So when we combine a term, each term has, as I said, here has a coefficient. So the coefficient for y, for example, is +7. The coefficient for x is -2. For y is -4. When we combine the terms, we actually combine the coefficients here. So we combine 3x with this one. So we're going to bring this over using the commutative property to change the position. So we're going to bring this over here, -2x, with the sign. Then we're going to move these back with its sign. The sign for y is negative. We're going to bring it next to the similar or like term, which is +7y. And you go ahead and combine. So if you have 3 of something, x is a variable, could be unknown, it could be something that we know but it changes. It could be money, people, fruits, animals, whatever. If you have 3 of something minus 2 of the same thing, what's the difference? What's left here?
Do have to subtract it, make it 1x, right?
That's right, exactly. 3 combined with -2, we get 1x. Over here, combining -4 with +7. This is what we studied last time with the number line. What is this equal to?
3y.
That's right, so this is +3. Exactly, so that's why these two turn into 3y. And as you can see now, this expression turns into this. It's still the same expression, but this one is reduced and simplified. Can we add up these two?
No,
Not right. Why not?
because different symbols.
Exactly. So these are not like terms. It's the opposite. They're unlike or dissimilar, unlike terms. Don't add up. Don't add up or don't combine. It's like adding oranges and apples. You can't say 4 oranges or 4 apples. You just, they stay like this, stay what they are. 1 apple, for example, and 3 oranges, and that's it. That's not change. Totally 2 different items. Okay, so we combine like terms. And we combine them again, we're using the rules of addition and subtraction. When you distribute, you're multiplying basically the signs, but when you combine like terms, you're actually adding and subtracting. That's why I told you last time, the rules of the signs are very important here. You don't want to miss or get a sign wrong. If you get one sign wrong, the whole expression could be wrong. Let's take another one here. All right, for this expression here, we added some parentheses and some more numbers. Let me make this a 7 here, 7x. And let's go ahead and simplify this. So what do you think we do first?
Distributive property, right?
Exactly. So the distributive property, whenever you see parentheses, summation needs to be
What's 10x?
Let's make this a negative just to make it a little different than before. So we're going to multiply these two first. It'll be negative.
Yeah, so it'll be negative 10x.
And then?
Positive minus positive 5 because it's
Negative times. Okay. Negative times negative would be positive.
Positive, yeah. Okay.
And just going to bring these over because these are not inside. We're not multiplying.
So bring those down.
That's right. Now we go ahead and
like terms.
Combine like terms, exactly. So negative 10x combined with
7x, so it'll be negative 3x.
Very good. So negative 10 with positive 7 will be negative 3x. Again, negative 10 plus 7 is like this. We're just combining the coefficients, we get negative 3. That's where this negative 3 comes from. And don't forget the variable. And of course, we need to combine these two.
That's 5.
Positive 5 minus 10, that's right, is negative. Negative 5. Okay.
Negative 5.
And that's basically the answer here. These are different, so we don't need to subtract anymore. This has x, this doesn't. Completely different terms. That's a variable term. This is a constant. So we can't do anything else with them, just like these over here. And that's pretty much the answer here. You may have a scenario like this. Doesn't matter how long the expression may look, the concept is the same. We try to combine all the similar things together, whether we have 2 of them or 10, put them together, and try to get the expression as simple as possible. If you look over here, see the expression was long, multiple things and terms and parentheses. We turned it into a much, much simpler expression. They're the same. You would rather see this than see this as an answer, for example, to something. Again, what is the first thing here? Do we add first or do we do something else? In this one here. Where would you start from this expression? If you think of what PEM does, it's about the same thing.
You would start with the 3 times x.
That's right.
Is 4.
That's right. So basically, just like we order of operations. Parentheses, you would try to start inside if there is anything to combine. There's nothing, no similar things here, unless you had 2x plus 4x, you would combine them. There's no exponents. Then you go to the multiplication, which is what you said is the distributive property. So we go to the multiplication. So do not add yet. A lot of people make this mistake. Addition comes last here, or the last thing you want to do is add or subtract. So do not add yet. Just bring the 7 down. Distribute this. Whatever the sign might be here, you got to multiply. Don't ignore this sign. It's important. This sign pretty much belongs to 3. You want to times these signs and then times again. Positive 3 times positive x. Positive 3x and then again positive times negative. Be negative 12. Bring down the other numbers. Okay, so that's the first step you want to do here, just like here. You want to clear the parentheses. Okay, then combine like terms. Same thing here, so clear. Number 2 here, we're going to combine like terms. All right, so what are we combining here? Look at this one. We can combine it with this. All right, what is 7 take away 12? 7 minus 12. You will also combine 3x with negative 5x. So again, when you move a term, move the sign with it. The sign of the coefficient is to the left, next to negative 5x. Okay, gonna move these together. Finally, we have this negative 10. Let's put this here for now, and later we will combine with the result of this. What's 7 take away 12? Again, the signs are important and crucial, as we learned last time.
Negative 5.
That's right. You still struggle with the signs, you need to rewatch the previous lecture as many times as needed. This is negative 5. And what is positive 3 minus 5? Positive 3 minus 5 is?
Negative 2. X.
Negative and x. This one has x, we added. Negative 10. And one last thing, we still have some like terms. We can combine these two together. Negative 2x, no like term. What's negative 5? Take away 10.
Negative 5.
Not negative 5. They're both negative this time. They're both negative, unlike here.
15.
Negative 15, that's right. Same sign, keep it and add, negative 15. And that's pretty much it. That's the final answer. There's nothing else that we need to do. Okay, very important. Again, the signs. When combining, we actually combine the signs or the coefficients. So it is essential that we know the signs very well. Everybody else, you guys okay so far? Everybody else, any questions at this point before we move on to another example?
No, sir, no questions.
All right. Let's say you want to combine this plus 5x to the second. Here's another expression with a bunch of terms here, variables, different powers. So, do we have a like term to the first one? We have x to the 4th. Do we have a similar term to this one in this expression? Basically, we're looking for a variable, same variable, same power. There's no other term with x4. It's basically that stays the same. We bring it over, bring it down here. What about the second term? Do we have a similar term to it? Second term here, can we combine it with anything in this expression? Or, by the way, what is the power of this variable? This one is 4, this one is 2. What is the power here of this variable? The invisible power is what? What exactly? Yes? It's 1. Same thing here, the invisible power is 1. So we can combine these two, they're like terms. This 5x is second, positive 5x is second, doesn't have a like term, we can put it over here next to the first one. But these two can be combined together, so we have negative 3 minus 8, which is negative 11, x, 1. All these now are different, even though the variable is the same, the powers are different, so we can't add them. So again, these are called unlike terms. So like terms, let me add that little note here. Can you complete this sentence for me? Like term must have the same what? Like terms must have the same. Everybody, like terms, what do they have in common? Same letter or variable, either x or y or z or a or b or c. And what else at the same time? The same variable. And what else? As we saw here, you have to have the same. If you look over here, you have to have the same power, okay? Not just the variable. Like terms must have the same variable and power. That's important. Okay, so like terms, they must have this. If they don't have the same power, as you can see here, you can't add them. You have to have same variable, the base, and also same power. Otherwise, they will be different. You can't add them. You cannot add 3 and 5 here because the powers here are different. And that's pretty much how you simplify your algebraic expressions, okay, using these properties that we've learned, the commutative property mainly and the distributive property. And any other property that you might see from these in the expressions, feel free to use it to simplify your expression. Pretty much the lecture for the day, for today. Any questions, everybody? Gavin, James, Maricela, Avel, any questions about any of this stuff?
No.
Everybody else, you guys good?